everyone. We have studied range, quartile deviation, mean deviation under the measure of dispersion in the last class. Today we are going to learn about standard deviation, that is under the absolute dispersion, and relative measure of dispersion, that is under the relative measurement of dispersion, that is coefficient of variation. So, we have studied range and coefficient of range, quartile deviation and coefficient of quartile deviation, mean deviation and coefficient of mean deviation. In this video, we are going to study about the standard deviation and coefficient of standard deviation, or in another word you can say covariance, coefficient of variation. So, standard deviation is the most important measure of dispersion. It is widely used in the statistical tools. So, here standard deviation means how the data or how the particular observation scatter from the data set or scatter from the mean. Then why do we need to study the coefficient of variation here? See, in the standard deviation, we will come to know how the variable varying, and we are going to take which variable will be having more variation. That is what we are going to study in the standard deviation. But in order to compare between two variables, say height of the person and weight of the person, so we can calculate the standard deviation individually with respect to the height of the person and weight of the person. But in order to compare between these two, we are not going to take it in the standard deviation, because we can only calculate only one measurement there. So, in order to compare these two variables, say height of the person and weight of the person, we will have to take relative measure of dispersion, because you may have different units of measurement here. You can take height of the person, then unit of measurement is, it is in the centimeter. If you take the weight of the person, then the unit of measurement is kilograms. You can see here you will be having two different unit of measurements. In order to compare these two, we will have to enter into the coefficient of variation. In that, we can easily compare between two different measure of units here. So, let us see how we are going to calculate the standard deviation under two different scenarios here. So, one is deviation taken from the actual mean and deviation taken from the assumed mean. Okay. So, let us see the first one, that is deviation taken from the actual mean. In order to calculate the standard deviation under the deviations taken from actual mean, we will have to take the x variable, individual x variable minus actual mean, that is average or arithmetic mean, you can say. We will have to take that value divided by number of variables here. This is with respect to individual series. When we do not have frequency values, we have only variables, that is individual series, ungrouped data. We will have to use this formula under the actual mean. Yes, let us see this example under deviation from the actual mean for individual series. Calculate the standard deviation from the following data. Here we can see that we do not have any frequency values, we have data only, that is ungrouped data. In that, how we can calculate the deviation, that is standard deviation from the actual mean. For that, you will have to take the given data. You can consider it as x variable, that is 14, 12, 9, 15, 20, 17, 12 and 11. Now, we will have to take the sum of this variable, that is we will have to use we will have to take the summation of x here, that is 120. Now we will have to calculate the x bar by using the formula summation x bar x by n, where summation x is 120 and we have 8 variables, hence n value is 8 is equal to 15. So x bar here is 15. Now we will have to take this 15 as a constant value for each data and we need to calculate the value x minus x bar. Suppose for the first one take 14 minus 15, second one 22 minus 15, 9 minus 15, like that we will have to do it for the individual case. If we do like this, we will be getting the values like for the first one minus 1, for the second one 7, then minus 6, 0, 5, 2, minus 3 and minus 4. So now we will have to square these variables, we will have to square these values. So if we consider first one minus 1 square is plus 1, then 7 square 49, 6 minus 6 square 36, 0 square is 0 only, 5 square 25, 2 square 4, minus 3 square 9 and minus 4 square 16. Now we will have to take the summation of this value, because in order to calculate the standard deviation under actual mean, we will have to take this summation of this value, that is x minus x bar whole square. So answer will be 140 for that. Take that value into this formula. So square root of 140 divided by 8. So answer will be square root of 17.5. So that if we take this square root, we will have to get the answer 4.18. So this is the standard deviation value. So this is under the deviation from the actual mean. As we have studied now, we have two methods in order to calculate the standard deviation, that is deviation from the assumed mean and deviation from the actual mean. This is about the deviation from the actual mean. Next you can consider the second one, that is deviation taken from the assumed mean. Formula will be sigma is equal to square root of sigma d square by n minus sigma d by n whole square. Here this is sigma d square only, but here we will have to take sigma d by n whole square, where this small d is equal to x minus a, that is nothing but deviation from the assumed mean, where a is equal to assumed mean. So let us get into this question now. The table below gives the marks obtained by 10 students in statistics. Calculate standard deviation. Here this is not frequency, don't get confused here. This is not frequency value. This is just student number 1, 2, 3, 4 like that we will be having 10. So here you have an example under deviation taken from assumed mean. Again here we have ungrouped data only. It is for individual series. We do not have frequencies here. You have numbers here like student number from 1 to 10, but it is not frequency here. Now, student number is different. They have just given the numbers to the each student, that's all. But it is under individual series only. So consider their marks. So you have marks with respect to the 10 students. Now let us calculate the standard deviation under assumed mean with respect to this question. For that you will have to take the numbers from 1 to 10, then you can take the given data, that is marks of 10 students. Here we will have to take the D, that is x minus A, where x is individual x marks here, whereas A is equal to assumed mean. Here I am going to, you can assume any value from this x series. I am going to assume this one has the assumed mean, that is 57. If we consider this as assumed mean, take the constant value as A is equal to 57 and subtract 43 from 57, 48 from 57, like that you will have to do it for each x variable. If we do like this, we will be getting the values like minus 14, minus 9, 8, 0, minus 26, 3, minus 20, minus 9, 21, 2. So now we will have to take the square of this D. So if we consider first one, square of 14, minus 14 is 196, you will have to take minus 14 into minus 14, that is plus 196. Then minus 9 square is 81, 8, for that you have 64, 0, 6, 76, 9, 400, 81, 441 and 4. Now here you will have to take the total of D, that is summation of D and summation of D square. So summation of D is minus 44 and summation of D square is 1952. After getting these two values, you can easily calculate the standard deviation by applying this formula, that is square root of sigma D square by n minus sigma D by n whole square, where sigma D square is, see here sigma D square is different from sigma D whole square. Sigma D square is not equal to sigma D whole square. This one is different and this one is different here. So now you just take these two values, sigma D square is 1952 divided by 10 minus sigma D is minus 44 by 10 whole square. You will have to take the square root here. Now you can solve this equation. You will have to get 195.2 minus 19.36, that will give you square root of 175.84. So finally you will have to get the standard deviation value is 13.26. So this is the standard deviation value under assumed mean method. So this is under the calculation of standard deviation with respect to the discrete series. Previously we have studied with respect to the individual series, and this is under the discrete series. So we have three methods under discrete series. One is actual mean methods, assumed mean methods and step deviation methods here. So how you are going to calculate the standard deviation under the actual mean method is, you will have to take the square root of summation f d square divided by summation f, where f is equal to frequency. So here this is for assumed mean method in order to calculate standard deviation. So formula will be sigma is equal to square root of summation fd square by summation f minus summation fd by summation f whole square, where d is equal to x minus a. Here you will have to take the assumed mean. Then capital N is equal to summation f. You will have to take the total frequency here, sum of total frequency. So this is the question under assumed mean method in order to calculate the standard deviation. So calculate standard deviation from the following data. Here you can see you have x variables and f values you have. By using x and f, you will have to determine standard deviation value. So here you have a solution for that question. So deviation from assumed mean, for that you will have to take x and f as it is. Now you will have to calculate the d value. So d is equal to x minus a, where a is equal to, I am going to take 31 as assumed mean here. If you want, you can take either 20 or 22 or 25, whatever from the x variables. I am going to take 31 as a assumed mean. So by taking a is equal to 31, you can take d is equal to x minus a. So take 20 minus 31, 22 minus 31, like that you will have to find out the d value for each variable. So we will be getting the values like minus 11, minus 9, minus 6, 0, 4, 9, 11, 14. So here I have taken the total of f, summation of f, or you can also determine by capital N, this one, that is nothing but 107 here. So here after calculation of d, we will have to calculate the d square. So you can take the square of these values. So for 11, minus 11, you will have to take minus 11 into minus 11, that will become plus 121. Then you will be having 81, 36, 0, 16, 81, 121, 196. So after calculation of d square, you will have to calculate the fd and fd square. So for that you will have to take the multiplication of second column and third column in order to get fd. So for the first one, f into d, that is 5 into minus 11, that will become minus 55. Like that you will have to multiply this value, second column value, with third column value. So you will be getting the values minus 55, minus 108, minus 90, 0, 100, 126, 110 and 84. At the same time, you will have to calculate fd square. So for that you will have to take f values and d square values. For the first one it is 5 into 121, then 12 into 81, 15 into 36, like that you will have to calculate the values. So we are going to get the values like 605, 972, 540, 0, 400, 1134, 1210, 1176. After calculation of these two values, you will have to take the summation. So summation fd and summation fd square. For summation fd, you will have to get 167, then summation fd square is equal to 6037. Now you can apply this formula here. Sigma is equal to square root of sigma fd square by sigma f minus summation fd by summation f whole square. So for sigma fd square, here you have that value 6037 divided by you can take this value summation f or capital letter N, that is 107 minus summation FD value. So, summation FD is 167 by summation F is 107 whole square. You will have to solve this equation now in order to get sigma. So, 56.42 minus 2.44. So, you will have to get 53.98. So, finally, you will have to get the sigma value is equal to 7.35. So, this will be the sigma value under this problem. So, next is step deviation method. Here you will have to take one more value, that is into C. You will have to take the class interval here. So, here you will have to take sigma is equal to square root of FD dash square divided by N minus sigma FD dash by N whole square into C. You will have to take that C out of the square root. So, let us see this example here. Compute standard deviation from the following. Here you can see you will be having this marks in series like 10 to 20, 20 to 30, 30 to 40, 40 to 50, and the size of this class is 10. So, 10 to 20, 20 to 30 you have 10, 10 difference is there. So, a C value will be 10. Then you will have to take the number of students here, that is nothing but frequency. So, marks is x variable and number of students is f. So, now you will have to solve this question by taking the table like this. So, here you can see you will have to take the marks as it is, then take f as it is and calculate d dash there. For that, take x minus a by C, where a is equal to 30. I am going to take 30 as assumed mean here, and 10 means difference between these two, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. It is in discrete series and the size is means difference is 10. So, you can calculate the d dash here. So, x minus 30 by 10. So, 30 and 10 is common here. You will have to take the x value individually here. So, for the first one, you will have to get the value minus 2, then minus 1, 0, 1, 2, 3. Now, you will have to calculate the FD dash, that is f into d dash. So, 8 into minus 2, 12 into minus 1, like that you will have to calculate here. So, for the first one it is minus 16, then minus 12, 0, 10, 14, 9. Then you can calculate the FD square here. So, for that you just take the d square here. D square is minus 2 into minus 2, you will have to get plus 4 into f into d here into f, that is 8, you will have to get the value is 32. Similarly, you will have to do it for the remaining values, that is 12, 0, 10, 28 and 27. So, you need to calculate the total value here, that is summation f, or you can say capital letter N, both are same, that is 60, and you will need to calculate summation FD dash, that is 5, and summation FD dash square, that is 109. After getting these values, you can easily calculate the sigma value, that is standard deviation value. As I told you, you will have to take C is equal to 10 here. So 109 by 60 minus 5 by 60 whole square. You will have to take this 10 out of this square root. So 1.817 minus 0.0069 into 10 1.8101 into 10. So, you will have to get the value is 1.345 into 10. So, that will become 13.45. So, standard deviation for this example is 13.45. Next is calculation of standard deviation when you have continuous series. So, again here you can see for the previously you have discrete series, but in this you have continuous series, class interval you have. For that you will have to apply the same formula, sigma is equal to summation fd dash square divided by n minus summation fd dash by n whole square into c, where d dash is equal to m minus a by c. As I told you, c is equal to class interval here. You will have to take the size of the class interval. Let us see this example under continuous series. The daily temperature recorded in a city in Russia in a year is given below. So, you have temperature in Celsius, number of days. Calculate the standard deviation for this particular data. So, now you will have to take the x variable, that is temperature. It is in continuous series. For when you have continuous series, you will have to take the mid value. So, mid value is equal to, mid value is small m. Then number of days is nothing but f. So, here you will have to calculate the d value by using assumed mean method. So, d is equal to m minus a by c. If you consider it as d or d dash, both are same. So, now you can calculate the mid value for this. So, you will have to get the value is, so minus 40 minus 30 divided by 2, minus 30 minus 20 divided by 2, like that you will have to calculate. You will have to get the values like minus 35, minus 25, minus 15, minus 5, plus 5, plus 15, plus 25. If we take the total of this number of days, that is f, you will have to get the value n is equal to 365. So, after calculation of that n, you can calculate the d dash. For that, you will have to take m minus a by c. Here, I am going to take minus 5 as a assumed mean and c is equal to 10, as you can see here difference between 40, these two means lower limit and upper limit is 10. So, 40 to 30, 30 to 20, 20 to 10, 10 to 0, 0 to 10, 10 to 20 and 20 to 30. So, you will be having a size is equal to 10. So, you will have to get the value is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3. So, after calculation of d dash, you can calculate the f into this value, that is d dash. For the first one, it is minus 30, for the second one minus 36, then minus 30, 0, 65, 360 and 60. Then you will have to calculate the fd square. So, for fd dash square, you will have to multiply this value 2 times, that is minus 3 into minus 3, then multiply by f value 10, minus 3 into minus 3 into 10, minus 2 into 18. Like this you will have to do here. You will have to get the values 90, 72, 30, 0, 65, 720, 180. So here we will have to take the summation of fd dash and fd dash square. So for fd dash it is 389 and fd dash square it is 1157. Now you can take these values into there in order to calculate standard deviation. So you can take these values 1157 divided by n value, that is 365, minus of 389 by 365 into 10. We will have to get 3.1699 minus 1.1358 into 10. So difference between these two is square root of 2.0341 into 10. Take that square root, you will have to get 1.4262 into 10. So finally you will have to get sigma is equal to 14.26 degrees Celsius. So this is the standard deviation value for this particular question. Next is combined standard deviation, and you will have to calculate the combined mean as well here. So when we have individual mean values, say for n1 item we will be having sigma 1 standard deviation and x bar 1 mean, and for n2 items if you have sigma 2 and x bar 2, we can easily calculate the combined mean and combined standard deviation. So this is the formula in order to calculate combined mean. That is x12 bar is equal to n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. Then in order to calculate combined standard deviation, this is the formula here, that is sigma 12 is equal to square root of n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n2, where d1 is equal to x12 bar minus x1 bar, that is you will have to take the combined mean minus x bar 1, that is mean from first item. Then d2 is equal to again x12 bar, that is combined mean, minus mean from the second item, that is x2 bar. Here you have an example in order to calculate combined mean and standard deviation. Let us see this example here. Particular regarding income of two villages are given below. You have two villages here. For that you will be having number of people, average income and standard deviation of income. So number of people is nothing but n here, that is 600 for A, village A, and 500 for village B. then average income is nothing but x bar here. So this is x1 bar and this is x2 bar. Then standard deviation of income means sigma. So sigma 1 and sigma 2. You will have to calculate combined mean and combined standard deviation here. So here I have taken given data, that is N1 is equal to 600, N2 is equal to 500, X1 bar is equal to 175, sigma 1 is equal to 10, then X2 bar is equal to 186 and sigma 2 is equal to 9. Now you just take this formula, that is combined mean x1 2 bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2 in order to calculate combined mean. So take n1, that is 600 into x1 bar 175 plus 500 into 186, that is with respect to n1, n2 and x2 bar. Take n1 and n2, that is 600 and 500. So you will have to get the values in the denominator like this. In the denominator you will have to get 1100. So finally you will have to get the numerator value 1,98,000 divided by 1,100,000. So combined mean is equal to 180. So that is the combined mean here. So now you can calculate the combined standard deviation by using this formula. In order to calculate combined standard deviation, we will have to take n1 sigma 1, n2 sigma 2, then d1 and d2 here. So how will you calculate d1 and d2? You will have to take d1 is equal to x12 bar minus x1 bar. So it is the combined mean minus mean from the first item. d2 is equal to x12 bar minus x2 bar. This is again combined mean minus this is the mean from the second item. So you will have to take 180 minus 175, that is 5, then 180 minus 186, that is minus 6. So d1 is equal to 5 and d2 is equal to minus 6. So now you can calculate the sigma 12, that is you can take the square root of that, apply the values into here. So 600 into 100 plus 500 into 81 plus 600 into 25 plus 500 into 36. You will have to calculate each values separately divided by 600 plus 500. You will have to get the values is 60,000 plus 15,000 plus 18,000 divided by 1,100. So in the numerator finally you will have to get 1,33,500 divided by 1,100. So 121.364. If you take the square root of this value, you will have to get the combined standard deviation, is equal to 11.02. So, this is the combined standard deviation value. So, from this we will come to know about few merits and demerits. So, it is helpful to calculate the data regarding the measure of dispersion, and here it will not be affected from the extreme values, but when you compare with the previous measure of dispersion, it is very difficult to calculate and analyze, but you can use these values for the further mathematical treatment. Then if you compare, if you take standard deviation, then it is very easy to compare the variation among the variables. So, this is regarding the standard deviation. Let us see the coefficient of this standard deviation, that is coefficient of standard deviation, in the next class. Thank you.